Hi. And so finally, let's have a look at the sort of test question that could be asked using the Hardy-Weinberg equilibrium equations. So here we've got, as usual, I've made something up, and anyone who writes a test will have made up many of these. And I've just made up a kind of bird, and it's a red-winged warbler and a yellow-winged warbler. And so the idea is that they're the same species because they can interbreed, and we've got a case where the dominant allele, the capital R, codes for the red wings, and the recessive allele codes for the yellow wings. And so here's my question. If 17% of the population have red wings, what's the frequency of the capital R allele? And so you've got to remember this is looking at the kind of population where there's not massive change. It's not suddenly got cold in Alaska and loads of these birds have flocked down to Washington State to interbreed with these ones. There isn't a huge mutation rate. It is a large population, so there won't be too many statistical anomalies when one or two die. And so we've got to consider those assumptions when we do this kind of question. But now let's start. One thing we know about this is that, well, there's two possible genotypes for this phenotype. It could be homozygous dominant or it could be heterozygous. But this one, we know, is homozygous recessive. So that's always the one we have to identify. But we don't have it. We've got 17% of the population has red wings. And so we know that 1 minus 0.17 have yellow wings, and so that ends up being 0.83. And so we know that the number of yellow-winged birds is 0.83, or the frequency of those is that. And that, of course, is the Q squared term. So the Q squared term is the same as that genotype and that yellow-winged phenotype. So we know that, and that's pretty good. Now we can work out the frequency of the Q allele, because the frequency of Q is the square root of Q squared. And the square root of Q squared, when I worked that out, which I did earlier, is 0.911. And so that is the frequency of Q. Now, the frequency of P, because P plus Q equals 1, the frequency of P is 1 minus Q equals 1 minus 0.911, which equals quite a small number. It ends up being 0.09, I think, something like that, or 9%. So even though the 17% that show the red wings, the frequency of the dominant allele, capital R, is only 9%. 0.09 is its frequency. And so this might be a 911 emergency for the dominant allele. But yeah, this kind of question is the kind that pops up in exams all the time, and all you have to do is identify Q, because you know that Q squared is going to be the frequency of the recessive phenotype, because the recessive phenotype has only one kind of genotype, and that's always it's always homozygous recessive. Can't find it.